analysis of clock sequential circuits. So we have a sequential circuit. Now what is a clock sequential circuit? Any circuit which has flip-flops in it is called a clock sequential circuit. So this is a clock sequential circuit where we have D flip-flops. There is a clock also. Both the circuits are being clocked together with a clock. So first step is, this is a clock sequential circuit. First step is write the state equations for this. State equations for this given circuit. What are the state equations? They are called next state. The output of this. So this is the state equations. What is the ATP plus 1? It is equal to D. This D. And what is this D? This is D is equal to X A X B. So AX BX, this is D. What is the next state equation of B? This is B. This is equal to, I can write this as DB, I can write this as DA. So this is DA, this is DB. What is DB? It is X. Or one way of writing is, you can write it as A, present state of A into X plus present state of B into X. This is present state of A bar into X. And what is Y? Y is the output. X is the input, Y is the output. Y is A or B. So present state of A or with B, and with X bar. So I can write it as A plus B into X. So these are called the state equations. You should know how to write the state equations. Next thing important is how to make the state table. State table. For every clock sequential circuit, we have to write the state equations and we have to make a state table. These are the two important things. Then how to make the state table is, there are two flip-flops, so there will be two present states. I'll have AT, this is the present state. Then I have an input X. Then I have next state. And then I have the output Y. When they are 0, 0 and X is 0. When the present state is 0, 0 and X is 0, what is the next state? X is 0. Okay. You can write this as A plus B into X. So what is the next state? X is 0, it is 0. And what is this? X is 0, this is also 0. If X is 0, then the next state A and B will be 0. Okay. So for every combination of states, X will be 0 and 1. Now in next, A and B is 0, 0, X is 1, then also it is 0. A bar X, what is A bar? 1, X is 1, this will be 1. This way you have to make the state table. Then X is 0, these are both 0, 0. Then A plus B will be 1, 1 into 1 will be 1. What about this? X is 1, what is A? A bar T, A bar T, A is 0, A bar will be 1, so this is 1. Then next, A plus B is 1, X is 0, so ये तो 0 होगा. जहाँ X 0 होगा, ये 0 हो गया. Then A plus B is 1 and this is 1, so this is 1. What about this? A bar is 0, A is 1, so A bar is 0, so this is 0. And last, A plus B is 1, 1 plus 1, 1 or with 1, and this is 1, so this is 1. So this is the state table which will decide what are the next state outputs. And what is Y? Y is A or B into and with X bar. So here X bar is 1, A or B is 0, so Y is 0. A or B is 0, so Y is 0. There is no need to think about X bar. A or B is 1, then what is X bar? 1. A or B is 1, what is X bar? 0. So A or B is 1, what is X bar? 1. A or B is 1, what is X bar? 0. A or B is 1, what is X bar? 1. So this is why. This is the state table. How to write the state table? You should know how to write the state table. Next important thing is how to draw the state diagram. For the state diagram on this. So if you have 0, 0 as the input, if X is 0, next state is 0, 0. X is 0, next state is 0, 0. And what is the output? Y. So X, Y, and within this it is state. Then when X is 1, it goes to state 0, 1. When X is 1, it goes to state 0, 1, and what is the output? 0. I can make another state table which will be a reduced one, but how it will appear? Present state, then next state for X equal to 0, for X equal to 1. If it is 0, 0, 0, 1, 1, 0, 1, 1. For X equal to 0, state is 0, 0. For X equal to 1, state is 0, 1. For X equal to 0, state is 0, 0. For X equal to 1, state is 1, 1. For X equal to 0, state is 0, 0. For X equal to 1, state is 1, 0. For X equal to 0, state is 0, 0. For X equal to 1, state is 1. This is another form of writing the state table. And what is the output for X equal to 0 and X equal to 1? 0, 0, 1, 0, 1, 0, 1, 0. So this is another way of writing the state table. So it looks more smaller and more appealing. So when we are in state 0, 1, on X equal to 0, it goes to state 0, 0, and output is 1. And for X equal to 1, it goes to state 1, 1. For X1, output is 0. When you are in state 1, 1, for X equal to 0, it goes to state 0, 0. Output is 1. For X equal to 1, it goes to state 1, 0. From 1, 0, for X equal to 0, it goes to state 0, 0. And for X equal to 1, it remains within the same state. Output is. So this is the state diagram for the given clocked sequential circuit. This is how you can analyze your given clocked sequential circuit. Let's have another circuit. Let's analyze a clock sequential circuit with JK flip-flops. can be any clock, positive edge triggered, but they should have the same clock. Both the flip-flops. So this is another clock sequential circuit with JK flip-flops. Now we have to start with the, you can say, the state equations. First write the state equations. What is A? What is A for a J flip-flop? What is state equation for this flip-flop? पहला क्या लिखेंगे? What is JA? It is equal to B, present state of B. What is KA? It is X bar and with present state of B. What is JB? It is X bar. What is KB? It is A XOR with X. So these are all present states of the two JK flip-flops. So determine the flip-flop input equations in terms of present state and state variables. So state variables are X and the present state is A and B. Second step is, what are the next state equations? तो कैसे करें? ऐसे ही बनाते हैं. There is no output, so will not have any output here. There is no output. When A is 0, 0, A is 0, 0, what is input X is 0. So what is JA, K? What is JA and KA and JB and KB? This will be for X equal to 0 and X equal to 1. What is this? X what are the, this is present state input. What is next state? What is JA? What is KA? What is JB and what is K? I have to draw next state equation still pending. And 0, 0, 0, what is JA? B. J is equal to B. So it is B 0, 1. What is KA? X bar into B. What is KA? It is X bar into B. B is 0, so this will be 0, 0. X bar into B, 1. X bar into B, X bar will be 0. X bar into B, so this is both 0. X bar into B, 1. 0. What is JB? It is equal to X bar, so it's just complement of. And what is KB? It is A XOR with X. So 0, 1, 0, 1, 1, 0, 1. So these are the equations of the flip-flop inputs. What about next state output? So if JK is 0, 0, next state output will be same as the previous one. JK is 0, 0, there is no change. When JK is 0, 0, again this is no change. 1, 1, that means when JK is 1, 1, the output is going to toggle. 1, 0, J is 1, K is 0. So it is going to be set. Previous value jo marzi ho. Both are 0, 0, that means it remains unchanged. Both are 0, 0, that means it remains unchanged. It is 1, 1, that means it is going to complement. And this is 1, 0, that means it is going to be set. This is one thing. If it is JB, KB, if it is 1, 0, it is going to be set. If it is 0, 1, then this value is going to be reset. Previous value jo marzi ho. Ye JK ka truth table hai. If it is 1, 0, it is going to be set. If it is 0, 1, it is going to be zeros, reset. If it is 1, 1, it is going to toggle. So previous value 0 hai, so the next value 1. If it is 0, 0, that means previous value remains unchanged. 0 hai to 0 it is. 1, 1, that means previous value will toggle. 1 ka 0 aa jayega. And 0, 0 means previous value hi rahegi, there is no change. So this is the state table for a given clock sequential circuit which is designed using JK flip-flops. So this is the table. This can be reduced to a smaller one, that when x is 0 it goes to 0, 1. When x is 1 it goes to 0, 0. When x is 0 it goes to 1, 1. When x is 1 it goes to 1, 0. When x is 0 it goes to 1, 1. When x is 1 it goes to 1, 0. When x is 0 it goes to 0, 0. When x is 1 it goes to 1, 1. So another way of writing the table is this. Now still we have not received the output equations. What will be the output equations for A and T? So it is next state equations for A and T will be, it is JA bar plus K bar A. So it will be B into T plus what is KA? Ka bar this X bar into A. So it is A bar B plus X bar plus B bar A. So A bar B plus X AX plus AB bar. So this is the next state equation for A, and next state equation for B will be JB B bar plus KB bar into B. What is JB is X bar. What is KB bar is A XOR X का bar. So B bar X bar, it is A XOR of X. So B bar X bar plus A bar X bar B plus AB X. This is the equations for next state equations for A and B. You have to write these equations. And final state diagram will be, we can state from 0, 0. When it is x is 0, there is no output. For x equal to 1, it remains within the same state. From 0, 1 on x equal to 0, it goes to 1, 1. X equal to 0. For x equal to 1, it goes to 1, 0. So, for 1, 0, from 1, 0, for x equal to 0, it goes to 1, 1. For x equal to 1, it remains within the same state. From 1, 1, for x equal to 0, it goes to 0. For x equal to 1, it goes to, it remains within the. So this is the state diagram for a given sequential circuit. Then we can do the same thing can be done with a T flip-flop also. We can have a T circuit and we want to analyze those T circuits. Then what will be the way of doing it? These equations were the characteristic equations for JK flip-flops. Let's have another analysis of a clock sequential circuit which is made up of T. So whenever you have a clock sequential circuit, both the transistors, the flip-flops, they will be clocked with the same clock pulse. So in this you can see both are negative edge triggered. There is a reset pulse also. Both have a asynchronous reset. कोई फर्क नहीं पड़ता. Then the input to first one TA and TB is through a AND gate whose one input is X and second input is B. So wherever there is a dot, there is a connection. And to T, next one, there is a straight input from X. And the output of both the gates, A and B, it is being ANDed together to get the final output Y. So here we'll have next state equations. What is TA? It is B into X. What is TB? It is X. What is Y? It is next state equations of A and B. Now what is A? It is T A bar plus T bar A. What is TA? Bx. So these are the next state equations for A. And what is the next state equation for B? You should remember the characteristic equation for T flip-flop. T B bar plus T bar B. What is TB is X. XB bar, what is X bar? So it is B XOR with X. This is one thing. Now what is next is, what will be the this? State table of this given circuit. What is TA? B into X. 0, 0, 0, 1, 0, 0, 0. What is TB is X. So 0, 1, 0, 1, 0, 1, 0, 1. Now we have to write A and B. So if TA is 0, what is next state equation? It will be same as the previous value. A is 0, TB is also 0, then next state output will be same as the previous value. If TA is 0, the next state equation will be same as the previous one. If TA is 1, the next state output will be complement of the 1. Again TA is 0, this is 0. TB is 1, so this will be complement. TA is 0, output remains the same. If TA is 1, it is complement. They are both 0, 0, so it remains the same. TA is 0, it remains same. TB is 1, so this will get complement. Again both are same. Both are 1, 1, so this will be complement. So this is the state table for a given function. And we can write the output also. What is the output? Output is ANDing of these two. No? Y. So Y out is the output. So it is 0, 1, sorry, 0, 0, 0, 0, 1, 1, 0. This is the output. So this will be the reduced table. Another way of writing the state table. This is state table. You should know how to analyze a clock sequential circuit. So for x equal to 0, what is A and B? Next state. 0, 0. This is next state. This is also next state. For x equal to 1, it is 0, 1. For x equal to 0, it is 0, 1. For x equal to 1, it is 1, 0. For x equal to 0, it is 1, 0. For x equal to 1, it is 1, 1. For x equal to 0, it is 1, 1. For x equal to 1, it is 0, 0. And then the output. This is the state table for the given. What is the state diagram? If you know this, you can write the equations. If you know this, you can write the table. If you know the state table, you can draw the state diagram. If it is 0, it is 0, 0. And what is the output? 0. If it is 1, it goes to 0, 1. What is the output? 0. If it is in 0, 1 state, for x equal to 0, it remains within the same state, the output is 0. For x equal to 1, it goes to 1, 0 state, and the output is 0. On 1, 0 state, for x equal to 0, it remains within the same state, the output is 0. For x equal to 1, it goes to 1, 1 state, and the output is 1. For x equal to 0, from 1 state, it remains within the same state and output is 1. And for x equal to 1, it goes to 0, 0 state and output. So this is a state diagram for a given sequential circuit. It's vice versa. If you know the state diagram, you can make the state table, you can find out the state equations and you can draw the sequential circuit. So this, just telling this is not important. I just want to tell you that we can work in both ways. If you know the state diagram, write its state table, minimize that state table, do the state reduction, assign the values to the states, write the state equations and then draw the circuit. Other way around, if you want to go, if you have a clock sequential circuit, write it equations, analyze the table, write the state table and then finally draw the state diagram. So this is all possible. So I'll talk to you about how to do state reduction and state assignment for a given state diagram in order to get a reduced circuit. Thank you.